So it's my great pleasure to introduce our next speaker, Dr. Isabelle Aubin. She is a forest vegetation ecologist at the Great Lakes Forestry Centre, which is part of Natural Resources Canada's Canadian Forest Service. Isabelle conducts research on how forest ecosystems respond to human-induced changes with a focus on understanding the response of understory vegetation to disturbances. Her research interests include forest ecology, plant community responses to disturbance, and the impacts of climate change on forest ecosystem. She collaborates with other researchers at the center, including on projects related to invasive species threats to Canadian forests. Isabelle has also published extensively in the peer-reviewed literature on topics such as plant community dynamics, forest management, and ecosystem responses to environmental changes. Isabelle's also, as Christian mentioned in the introductory, Isabelle's also leading our theme 1, and today she'll be presenting a talk entitled "A Tool to Assess Forest Vulnerability to Global Change." Welcome me, or join me in welcoming Isabelle to the stage.
Thanks, Kevin. Good. Okay, so yeah, so with this, I guess. Good. Okay. Okay, it works. Oops. Oh, I need okay, good. Yeah, made it. So yeah, I'm happy to speak just after Jürgen because I don't need to get to, I can skip some portion of my talk today. So yeah, maybe, sorry, we'll start back. Okay, so yeah, today I will present you some of the work we're doing in Team 1 to develop a tool that we hope can be useful for practitioners to get more of a sense of all the impact that all the global change impact have on our forest. So that's why I'm going back to what I was saying about the work with the presentation of Jürgen. He really showed us all the impact, all the global change impact that our forest will experience in the near future, and all the and showing that tree mortality also in Canada but elsewhere is happening. Oh, okay. Ça pas de l'air? Okay. So yeah, so we know all these impact is occurring, but it's hard to assess the vulnerability of Canadian forests to all these stressors coming because not all the regions are affected, exposed the same way. There's difference in local climate, in geography, in the environmental context, and also not all tree species are reacting the same way, responding the same way. They have difference in traits, they have difference in genetics, there's ecological interactions. So we know that there will be important impacts of global change on our forest. We know there will be some maladaptation, regeneration failure, change in the forest structures, in the composition of our forest. There will be some changes in stand productivity as well. In some region, we may have loss of forest cover. And we may also have important changes in the ecosystem function and services that we are gaining from our forest. But predicting these changes is very tricky, because there's so many, but also because we're moving outside of a historical condition, and then we don't outside the baselines that we have from the historical condition. So we are in novel condition, and it's hard to predict what is happening. But to manage, we need at least to try to get some prediction, and getting some prediction that we are able also rapidly to get information, so we can rapidly try different scenarios, thinking tool of what could happen, and trying to do our best to manage as Jürgen was presenting. Sorry, with the light, I don't see very well, so I may be a bit lost in my talk, but we'll make it. So one of the main objective of divers, as I was saying, is really to develop a tool that can be used practitioner to visualize the different vulnerability of the Canadian forest, but also to identify where we have a hotspot of vulnerability, where we have also some maybe cold spot or refugia, where it's for some stressors, the forest will be a bit less, may suffer less of this this stressor. And so having a visualization of that would be useful to inform adaptive management strategies. Whoops. Okay, so as Jürgen was saying, a key aspect is really the speaking the same language, or at least knowing we don't, for the same word, we don't mean the same thing. So for us, it's very important. The first step we're doing in the group is really to define the wording. Oh, I can see this one. I'm seeing what my slide. Okay, I will go with this one. So so that's very important for us, and we are using. So here you will see it's the framework we're using for framework for vulnerability, on how to assess vulnerability. With this framework, this is a framework that ecologists and conservation ecologists are using. It's from the fourth assessment of the IPCC. It's important to say that because the fifth assessment is more risk-centered and is more put more importance on the risk and also on the social aspect of the vulnerability. But for us, the type of work we're doing and to really include the ecological mechanisms, we are working with this framework, and many ecologists are still doing. So this framework is composed of three components: the exposure to a given stressors, to an environmental change, the sensitivity of the species that are affected by this stressor, and the adaptive capacity of the species, the capacity to adapt to the new growing conditions. So I can give you here an analogy to really see how we are playing with these different components. The analogy with the sunburn. You can be one person, very fair-skinned, very sensitive to sun, but if you stay in the house, no problem. You're not impacted by you're not impacted by the sun. But you can be two persons that go outside for the same amount of time. So they are exposed to exactly the same amount of time, but one person is fair-skinned, the other is more darker skin. So you know who will be more impacted, eh? So, and then you have a third scenario where the same person who is very sensitive to the sun in the spring may be adapted more in the fall, and when she will go in the outside to the sun, for the same exposure she will be less impacted. So to get just if we want to assess the vulnerability of someone to a sunburn, if we just check the time that the person stayed on the sun, the exposure, you will have an incomplete information. So you really need to know about the sensitivity, the exposure, and the adaptive capacity to get a comprehensive assessment of vulnerability. And it's the same thing for the forest. So I will go now with some data about forest. Here an example for exposure. So here the example we have here is the sugar maple stands in Outaouais region that you see that are, here you have 4 graphs. So the first graph that is up on the top left, yeah, is the current distribution. In gray is the current distribution of sugar maple stand in Canada that we plot against the temperature and the precipitation. So this is really the climatic niche of sugar maple in Canada. And in the blue, this is the sugar maple stands that are in Outaouais region. So the climatic condition where we have here our sugar maple stands. And what we've done in these 3 graphs, we've done for different projection, we have projected what will be the climate for this sugar maple in Outaouais. And what you can see is that with time, they get outside of the condition that sugar maple is used to grow in Canada. So it's outside their climatic niche. So that's what we considered as exposure to climate change in this situation of what we are within our work. Sensitivity. So for sensitivity, what we are doing, we're really focusing on the ecological mechanisms and that the trees species use to respond to these environmental change. And this so the tree can avoid, resist, or recover to these the change in conditions. And we use the functional traits to characterize these responses of the species. And from that, we're able to rank species using a relationship between function and traits. We are able to characterize the different mechanisms by which the species responds to climate change and which species are better for specific stressors or less affected or less sensitive or more sensitive to a specific stressor. Then the third component is the most tricky one. This is the adaptive capacity, which is at the crossroad of genetics and ecophysiology, and in our case, community ecology. So it's very complex to be, it's discipline that we're used to be developed in silos. So we really need to develop a language, to common language, and learn to work together. That's very critical. And also it's include so many different processes. So it's that are at different scale and at temporal scale and at different spatial scale as well, from an individual that will have a plastic response to a change in environment to phenotypic diversity, genotypic diversity, and also up to genetic exchange between species. So all this, it's including in the adaptive capacity, and but for now, it's not taken into account. One important thing is when I speak about adaptive capacity, I'm really speaking about the intrinsic adaptive capacity, so the capacity of the species to adapt, and not to extrinsic adaptive capacity, where we are more like adapting the forest to continue to respond to our needs. So it's a really different lens that we're having here. And it's important because we have species that are so broadly dispersed right now, and they are already covering such large environmental gradient. So there is adaptation across the species distribution, but for us, we are seeing black spruce, but in fact, black spruce is a gradient of individuals having different genetic, which impact their response to the change in environmental conditions. So that's very important. So we will try to include more and more the genetic diversity parameters, and we're using the framework that's been developed by Samuel, that is around, just out there, that developed this framework 3 years ago. And it's really, for us, it's really give us a roadmap on how we should start working on trying to integrate this more into our work. Then just to say rapidly that these new tools that we're developing them based on work that have been done the last now 12 years, work that is done with a large group of collaborators, only a few showed here, and it's been led by Canadian Forest Service, the Forest Change Program. Some Kathleen is here, and a few people are here as well from that program. And it's also based on work we are currently doing within the Team 1 of the Diverse Project, where we are trying to fill some critical knowledge gaps so we can improve the prediction. So there is 3 projects on wood ecophysiology that Simon and Zoe, I don't know, Simon is out, you're there, Zoe is there, okay. I don't think Hannah is here. So we have 3 projects that are really trying to fill some critical information. We have also Morgan that is doing some work on root ecophysiology, and she will present this afternoon about this work, so you can know more about the work. And we have also 2 other projects that are trying to document the inter and intra-specific variability that we have across the species distribution, with species so largely distributed in Canada. So we have the Fund Tree campaign. Some or many of you may have participated to it. So this is on the variation of wood density. And then we have a project on seed variation as well, in collaboration with the National Tree Seed Center. So while I'm here, it's to speak to you about the development of this tool. And why I'm speaking to you about that is because we want that you go to see Mathilde, who's there, and Morgan at the booth. We'll have during the poster session to discuss, because we want to have your input about how we should develop this tool. So I'm just giving you a rapid nutshell on what is the tool, and then from there you can go for a chat one-on-one with them. So this tool, what we want to do. So we will have indices of tree sensitivity to the main climate change stressors. And these indices are relative ranking based on traits. We have 77 Canadian tree species in our list of species. And the indices are made, it's really a set of indices. So for each stressors you have for the main mechanisms, some information if they are more sensitive or less sensitive, and different strategies. Anyway, you can go discuss with them. It's hard to discuss in a short time, but just really to say that it's not one indices, but different indices that you can use very tailored to your need into the project. Then with these indices, we want also to do spatial assessment of forest vulnerability. And to do that, we want to use for the different stressor the same reproductive data flow that is quite simple. It's really an integration of different layers of information. And the idea is that we could rapidly get a spatial view of the hotspot of vulnerability and what's happening into the landscape to the species, very an integrated assessment that intersect the exposure and the sensitivity of the species. And the idea is with that, you could rapidly, it's food for thought of thinking of what could happen for the different stressors into your, at the scale of Canada, but also, and also we have also, you can also zoom in at regional scales to see what's happening in your area. Also rapidly, we'll do that for, of course, for different projections. So we have an idea of how it's evolved in time. And also with different scenarios, because we think it's the emission scenarios, it's important, of course, to understand the range of impact, the potential impact, capture some of the uncertainties. But what I found even more important, it's also to get a sense of the impact of our choice on our forest. So are we reducing our short-term comfort and sticking closer to the Paris goal? Or are we just going business as usual? And because that's really the base, we think of adapting our forest. But first, if we don't reduce the emission, the impact will be very large. So just having the chance to play with the different emission scenario, we can see that our decision have an impact on our forest. So I think it's still important to really keep that in mind in our when we get these assessments. Then that's what we also, at working with geneticists, we're trying to include take into account the genetic indices, different variation of species distribution, and include the adaptive capacity with some of genetic indices into our work. It's tricky, but it's important. And then a big piece of it, we want to co-develop with some of you the interface where you have access to the tool. So that's the very first draft of what we can think of. So you can see the different maps in the same places, and you can decide which indices you want to add that is really tailored to your specific area. So if, for instance, is it only at the stand level? Is it at the population level? You want only individual level? All these information, you can take it into account and really play with adding different species, different time period, different scenarios, and you can really tailor to your needs, and you can change and adding food for thought of what could the potential impact can happen. This is all done with a large group of people from a lot of different disciplines. And our timeline, we're currently working on the trade documentation, and we start soon. We started yesterday, we can say. We started the index development, so we're there. And then we'll have a time where we'll do some beta testing with some of you. And so that's why we want you know about this timeline. And we hope we can share something on the next fall in a year. And the way it will be developed, we hope we can develop it so it can always be updated, but in more systematic way. Morgan is currently working on that, making sure we can update the information as soon as new information is coming up. So again, we want to have your view on it. We'll be at the booth, I don't know exactly where, but during the poster session. Oh, it will be just there. Where Kathleen and Madeleine are. So please come see us and have a chat. And there will be also a questionnaire you can answer online and all that. So thank you.